Today I'm going to explain about light reflection and refraction. Light reflection and diffraction already completed. So this is about electricity. So electricity we are discussing now. So electricity. Few problems also we need to discuss. So among that, so we are working on it. So we'll see how many possibilities, how many questions we can able to discuss. We'll discuss. So we'll try for the best to reach the best. Okay, so we'll see. So CBSE Grade-10 Physics electricity topic today we are discussing. Right? Okay. So in the previous class, so I explained about electricity, few topics. Electricity, few topics I explained. Now, few more topics we'll discuss now. Few more topics we'll discuss. So Ohm's law we have to discuss. Ohm's law. Those who are interested to take the courses, those who are interested to take the classes, so classes are available. So if you can take. So those who are interested about CBSE Grade-10 Physics. Hello, hi everyone. Welcome to the Student Brand. So this is our Shiva sir. So in the previous class, so I hope you already know about it. So I explained about, if you see the previous class, I explained about electricity until potential difference, electrical potential I explained. Potential difference and electrical potential I explained. So now we will work out on remaining topics. Okay. So remaining topics are nothing but Ohm's law. Ohm's law I will discuss. Ohm's law I will explain. Ohm's law and resistors are connected in series combination. Resistors are connected in parallel combination. And heating effect of electric current. These are the topics left over. Okay. So we'll work out on it. Resistors are connected in series. Resistors are connected in parallel combination. Okay. Resistors are connected in series combination and resistors are connected in parallel combination. So those topics we'll discuss now. So we'll see here how we can able to discuss, how best we can go it. We will go it. Chalo. Resistors are connected in series combination. Resistors are connected in parallel combination. Ohm's law will discuss. So now I'll explain about Ohm's law. Ohm's law. Those who are there in online, so just you can message to me if you have any doubts. So you can let me know if you have any doubts. Clear? So what is Ohm's law? Anyone? Can anyone tell what is Ohm's law? So the potential difference across a metallic conductor. So the formula is the potential difference. Definition first, then we'll go to the formula. So definition of Ohm's law is the potential difference across a metallic conductor across the ends of the metallic conductor, across the ends of the metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it, right? So I'm considering. So this is the resistor. This I am taking resistor, and here I am considering the switch. So here I am considering the switch. Resistor, switch, and this is a closed switch. Resistor, so switch I am taking here. Here ammeter, we can connect ammeter here. Ammeter, and so here I am considering switch cells 1, 2, 3, 4. So 4 cells I am taking. Now across it voltmeter is connected. Across it voltmeter is connected. Like this I am taking. So here I am considering voltmeter. So this is a resistor. So I am taking X and Y. So this distance, this length is X and Y. Okay, 0.5 meter. So key here ammeter. So current is passing like this. Current is coming from positive terminal to negative terminal. Current is coming from positive terminal to negative terminal, right? So in this case, positive terminal, negative terminal. Negative terminal, current is flowing like this. So we are adding, so we are connecting here. Like this, so current is passing like this, and here also. So you can check. So positive terminal, negative terminal, positive terminal, negative terminal. Current is passing in this direction. Current is passing in this direction. Okay. So it is reaching like this. It's reaching like this. So we can take along this way. Okay. So now Ohm's law statement. Ohm's law. So at a constant temperature, the potential difference across a metallic conductor, at a constant temperature, the potential difference across a metallic conductor is directly proportional to current flowing through it. So at a constant temperature, the potential difference across a metallic conductor, at a constant temperature, the potential difference across a metallic conductor is directly proportional to current flowing through it. Directly proportional to current flowing through it. Okay. At a constant temperature, the potential difference across a metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. V equal to IR. So this is the formula. V is directly proportional to V equal to IR. So here, so we can say, here I am considering that is a statement. So now materials required. What are the materials required? Materials required. So what are the materials? First one, 4 cells. So 1.5 volts each. So 4 cells 1.5 volts each. 4 cells 1.5 volts each. And a nichrome wire. nichrome nichrome wire nichrome wire nichrome wire is a combination of nickel, chromium, manganese and iron metals. Nichrome wire is a combination of nickel, chromium, manganese and iron metals. Nichrome wire is a combination of nickel, chromium, manganese and iron metals. So it is length is 0.5 meter, 0.5 meter length, 0.5 meter length. And third one is, so ammeter I am taking, ammeter, so positive, negative, and fourth one is voltmeter. Voltmeter I am taking, so voltmeter positive, negative. Okay, so switch and connecting wires, switch and connecting wires. So these are the materials required. These are the materials required. Switch and connecting wires. So switch is K, connecting wires. Okay, so these are the materials required. Coming to the process, first we have to connect one cell. We have to connect one cell. Connect one cell and take the reading of ammeter and voltmeter. Coming to the process. So procedure. So coming to the procedure. So connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter, and connect, repeat this process for 3 and 4, repeat the process for 3 and 4. So same process. So if you note down the values, so mention in the tabular form, I'm taking the tabular form like this. So here serial number of cells. So here ammeter reading, voltmeter reading and V by I form. Ammeter reading, voltmeter reading, V by I form. We are considering V by I form. Then so we can take 1, 2, 3, 4. So 4 cells, 1, 2, 3, 4. 4 cells we are considering. So after noting down, so you have to mention in the tabular form. If you draw the graph or VI graph, so the VI graph, it will be straight line, so linear. So you can check once. So VI graph is linear, so I am taking like this. So V on y-axis, I on x-axis. So VI graph is like this. It will be linear. Okay. So ohmic conductors. So what is ohmic conductor? So the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. The substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. So clear? So that is about ohmic conductors and non-ohmic conductors. So the graph is straight line, so linear. So the graph is linear. So you can check this one. So graph for ohmic conductors, non-ohmic conductors will be curve. So like this. So curve will be there. So we can take like this. So VI curve will be there. Okay. Now, so we'll go to the next one. Ohmic conductors, non-ohmic conductors completed. Resistors are connected in series combination. So we'll discuss about resistors are connected in series combination. So we are considering resistors are connected in series. Resistors are connected in series combination. Resistors are connected in series combination. So like this I am taking. Okay. So now we can see how we are connecting. So one resistor I am taking. and one more, and one more. So 3 resistors. So 3 resistors I am taking. So 1, 2, 3. So here ammeter, battery, switch, current is passing. So here you can observe resistors are connected in series combination. Resistors are connected in series combination. So I am taking here. So I am taking here. So here you can see. So V1, this is R1, R2 and R3. R1, R2, R3. So here V1, V2, V3. So R1, R2, R3, V1, V2, V3. So here entire circuit current is same. So entire circuit current is same, potential difference is different. Current is same, potential difference is different. Correct? Potential difference is different. So V equal to IR from Ohm's law. V equal to IR formula. So from V equal to IR formula you are considering. So Vs equal to, so series combination, right? So I am erasing here. So just check once. Vs equal to Vs. So Vs equal to V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So IRS equal to IR1 plus IR2 plus IR3. So we can take I common. I you can take common. IRS equal to I if you take common R1 plus R2 plus R3. R1 plus R2 plus R3. So now we can take I get cancelled. So RS equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So this the resistors are connected in series combination formula. Resistors are connected in series combination formula. So if you have any doubts you can ask. So those who have any doubts you can ask. So you can comment in the comment section if you have any doubts, right? And so resistors are connected in series combination. So this is the formula. If n number of resistors are connected in series combination, RS equal to NR. RS equal to NR formula. RS equal to NR formula. So this is the formula. Resistors are connected in series combination. If resistors are connected in series combination, means this is the formula. So note down. So note down, very very important. So try to note down. So you can take a screenshot or note down. Here, check once. Then I will explain about resistors are connected in parallel combination. So this is about resistors are connected in series combination. So now I will explain about resistors are connected in parallel combination. Okay. So if you have any doubts you can comment. So if you want any classes, tuition, so any classes from 6th to 12th, any classes, okay, so you can contact to this number. We can contact to this number. Okay, so this is the formula for resistors are connected in series combination. Resistors are connected in series combination. So now we'll go for resistors are connected in parallel combination. So I hope if you have any doubts you can let me know. So here you can see resistors are connected in parallel combination. The resistors are connected in parallel combination. So you can observe now. So here parallel combination. Resistors are connected in parallel combination. Parallel combination. Resistors are connected in parallel combination. I am taking. So now you can observe here. So this is one resistor. This is one more resistor. This is another resistor. So these three are in connected. So I am taking this ammeter here. Ammeter. So here sphere battery switch. So foundation classes. So foundation classes, if you want, you can ask. So from 6 to 12th, 6 to 12th, even foundation classes for 6 to 12th. So positive terminal physics, foundation classes for physics. Okay. So positive terminal to negative terminal current will pass. So this is the current. Here R1 I am taking, R2 and R3. R1, R2, R3. So current is passing like this. So potential difference is here. Potential difference, current is passing. So when the current is passing through the conductor, when the current is passing, so here current is dividing into three parts: I1, I2 and I3. I1, I2, I3 current is dividing. Here in this case current is dividing. Whatever the current is flowing, current is dividing in the circuit. Okay, so here you can see. So from Ohm's law, V equal to IR. This is the formula. V equal to IR formula. V equal to IR formula. So from this we can take I equal to V by R. I equal to V by R. I equal to V by R. So here potential difference is same for the circuit. For R1, R2, R3, potential difference is same. Potential difference does not change. So potential difference will be same, right? So only current is dividing. Only current is dividing. So only current is dividing. So we have to take the current. So I am taking the current. You can check. So if the current is dividing, okay, current is dividing. So IP equal to I1 plus I2 plus I3. I1 plus I2 plus I3. So potential difference in a parallel combination, if you are considering I1 plus I2 plus I3. So we can take a V by RP. V by RP equal to V by R1 plus V by R2 plus V by R3. V by R3. So we can see here, from this we can take V common. So from this we can take V common. B you can take common. So I am taking V common. V I am taking common. So if you take V common, so what you will get? 1 by RP equal to 1 by RP equal to, so V if you take common, 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So V will get cancelled. V will get cancelled. The formula is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the final formula is 1 by RP. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for resistors are connected in parallel combination. The effective resistance, equivalent resistance, or total resistance. So resistance formula if you are considering, so we can take 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, so that time we can take 1 by RP equal to, so n by R, so RP equal to R by n. So R by n. So this formula is very very important. So related to problems also they will ask. So make sure that so you are noting down this formula. So this formula is very very important. 1 by RP equal to, so R here, so RP equal to R by n. So note down this one. Note down. Note down. Anyone want classes, tuition? So if you can check once. Any doubt? Resistors are in parallel, resistors are in series. So this is the formula. I hope it is completed. So next we are going to the next one. So we can check. So one more I am going to the. So shall I rub it? Yes. So now I am going to the next one. So we can go with that heating effect of electric current. Heating effect of electric current. Electric current. Heating effect of electric current. So here heating effect of electric current is nothing but. So potential difference is given to the conductor is equal to, so work done on unit positive charge to bring one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point is called potential difference. So V equal to W by Q. So W equal to VQ. W equal to VQ. So we know rate of doing work is called power. So P equal to W by Q. So VQ by T. So in place of W we are substituting this value. In the place of W. So in the place of W. So we are substituting this one. So this is the combination. And so we know. So V into Q by T. So V equal to Q by T. So what is the Q by T? Rate of flow of charge. Rate of flow of charge is called current. So P equal to V into I. P equal to V into time. So energy is given to the conductor certain time. So E equal to P into T. So P into T. So in the place of Vp, so we are substituting V. VI into T. So here whatever the energy is given to the conductor, that will become into heat. So heat produced in the conductor. So in the form V equal to IR formula. V equal to IR formula. So we are substituting here. Then IR into I into T. So then we'll get H equal to I square RT. H equal to I square RT. So this is the formula. H equal to I square RT. So H equal to I square RT. H equal to I square RT. So each and every equation is a formula. So you can see V equal to W by Q, W equal to VQ, P equal to W by T. So VQ by T, V into Q by T. So energy P equal to VI, E equal to P into T, E equal to VI into T. So that how the heat is produced in the conductor. So H equal to I square RT. So heat produced in the conductor, that is nothing but H equal to I square RT. H equal to I square RT. Clear? So this is about heating effect of electric current. And also here heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Okay, so H equal to I square RT. H equal to I square RT. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to I square RT. So is directly proportional to resistance. Heat produced in the conductor is directly proportional to I square RT. So T is the time, right? Yes, T is the time. So rate of doing work is called power. So T is the time. Okay. So this is about heat produced in the conductor. So applications of heating effect of electric current. So where we are using these applications. So electrical kettle, electrical oven, iron box, and room heaters. Like this we can say. So these all examples we can take. We can go for heating effect of electric current. Practical applications, and next one related to this one, problems they will ask. Related to this one, problems they will ask. So we'll do one by one problems. So those who need, those who want problems, so those who want to do problems, those who want to do problems, you can join. So anyway, we are doing the problems also. So those problems are very very important to solve it. Actually, here related to electricity problems, they will few problems will come. Few problems will come. So related to resistors are in series, resistors are in parallel combination, and combined combinations also they will ask, and related to electrical power. And here normally quantization of charge, related to quantization of charge, related to electrical potential difference, and related to Ohm's law, and resistors are series, resistors are in parallel, and heating effect of electric current, related to energy, and related to current bill, and related to power, and related to potential difference. So related to each and every concept, there is a problem. So we can expect a problem from this concept. Okay, so that's enough. So this is about mm, so I hope you do you have any doubts. If you have any doubts related to concept, related to electricity, so let me know. We'll do problems also. So problems will do. So take little bit break. So after that we'll go for a problem solving. I'll explain problems also. So we'll do problems one by one. So those who are interested to join, you can join and let me know. I will do, yeah. So actually those chapters also I have to do it. Surely I'll try to do it. I'm not getting time. See, you can understand, right? So these chapters only I'm continuously working on it. That is the reason. So if any, sure I'll try. I'll plan and we'll see. So I'll plan ICSE and state syllabus, even foundation classes. I'm trying to plan. So I'll work out. So this time, because so these points are working out. Okay. So coming to the point. So I'll do remaining. How many are there? How many are there? CBSE. Shiva sir is. Hey, again you joined. So missing in the comment section. Where you went? So problems will do it. So few problems. So those are there in online. So after offline also, if you want to do it, so just check once. I will give a copper wire of resistivity. So problems I will work out. Oh, you only. Oh, very nice. Always the best, sir. Here I also subscribe from all channels. Hey. Nice. Nice to see you. Okay, done. So now you can see I am taking a copper wire of resistivity as a cross-sectional area. Calculate the length of the wire to required to make a 10 ohm coil. So so I am taking a copper wire. Say resistivity is given. Question. Resistivity is given 1.6 into 10 power minus 8 ohm meter, and area of the cross section. So A equal to 20 into 10 power minus 4, 20 into 10 power minus 4 centimeter square, and calculate the length of the wire. So R is given, R equal to 10 ohm. So length we have to find out. Can you find out length? Anybody? So if you are there, just let me know. So refraction, the bending of the light and interference of the two media is called refraction of light. Daniel? So you only created all the channels. Oh, nice, yeah. So students, try to solve it. Show your room please once. I am taking class, Daniel. Class is going on, right? So anyone? No one. I will only tell the answer. No problem. Here you can see. So it's okay. So we'll see some other time. Now class is going on. We'll see now later. So now you can see a copper wire resistivity is given, and area of the cross section is given, and resistance given. We need to find out the length. So now you can see. Okay, how to solve this one. So I'm taking here R equal to rho into L by A, R equal to rho into L by A, R equal to rho into L by A. So from this we can take so L. So anyway, resistivity is given, but here we need to understand one thing. So they given here, you can see here 20 meters or centimeters given. 20 into 10 power minus 4 centimeters given. So normally 1 meter equal to 100 centimeter. So 1 centimeter equal to 10 mm. So 1 meter equal to 1000 mm. So 1 meter equal to 10 power 3 mm. So here, so we need centimeter. So centimeter only given. From here you can take. Consider, right? So I'm considering here. Good evening, sir. Begin. Good evening. So here I am considering like this. Okay. So here I am taking. So 1 meter equal to 10 square centimeter. So centimeter equal to 10 power minus 2 meter. 10 power minus 2 meter I am taking. 10 power minus 2. Okay. 10 power minus 2 centimeter equal to 10 power minus 2. So here I am considering area. Area is given. So area, if you are taking area equal to 20 into 10 power minus 4. So into 10 square. So here square, right? So whole square if you are taking, this will become whole square. Then you will get 10 power minus 4 meter square. Then you will get 20 into 10 power minus 8 meter square. That is nothing but A. So now you understand ohm meter. So ohm meter, resistivity is ohm meter, resistance is ohm. Okay, now you can take. Okay, I'll give just let me solve this one. You can try it. So R equal to rho into L by A. So now you have to find out L. L equal to RA by rho. RA by rho. Correct? L equal to cross multiply. Then so use this formula. Use this formula and try to do it. So try to do it, remaining students. So remaining who are there in the class, so try to solve it. See, electricity problems, if you are solving, then only you'll get it. So along with me, try to solve. Remaining students, so do like, share, and follow and subscribe my channel. So how much you'll get the answer? Try to solve it. So here I am considering, here I am taking R equal to how much? 10, and area of the cross section is 20 into, so here I am considering 20 into 10 power minus 8 by, so that is R value, A value, this is A value, rho value is A value, this is rho value is 1.6 into 10 power minus 8. So here you can observe 10 power minus 8 is there. So here 10 power minus 8, 10 power minus 8 will get cancelled. 10 power 8 will get cancelled. Then what will be the remaining? So here you can take 200 by 1.6. Then again, if you do it 10 by 10, so you'll get 2000 by 16. So 16, 20, 125 you'll get 2000. So you can check once. The answer. Try to check once the answer. So you'll get the answer. So here 125 meter. So L equal to 125 meter. 125 meter. So this is the answer. Check once everyone. If you get this answer correct, then we'll go to the next problem. We'll go to the next one. So try to solve it, everybody. We'll do the next problem. Next problem also here same. Aluminium wire has radius. Radius is given and length given. If the resistance of wire is 10 ohm, calculate the resistivity of the aluminium wire. So next problem we have to discuss. Aluminium wire has radius 0.25 mm and length 75 meter. So length 75 meter. Okay, so the resistance of the wire is 10 ohm. Calculate the resistivity of the aluminium wire. Resistivity of the aluminium wire. So we have to find out the resistivity. Resistivity we have to find out. How to solve the resistivity? So I'll give the problem. Try to solve it, remaining students. So I'm going with the next one. So here you can see problems, electricity problems we are doing. So very important problems. So try to solve it. So aluminum wire has radius given. Second question, radius is given. Radius is 0.25 mm. 0.25 mm, and the length is given. Length is 75 meter. 75 meter. And if the resistance of the wire is, so resistance of the wire is given. So 10 ohm. and calculate the resistivity. So we have to find out resistivity. So try to solve it. Resistivity. Resistivity you can solve it. So anyone can do it. Resistivity. Try to solve the problem. So how to do it? I'll give the hint. After some time I'll give the hint. So those who want to do it, just to try this question. Those who want to just try the question. Children, try the question. Okay. So here you can see. So I am taking now. So here they given, here in this case they given mm. So this case they given. So in the remaining cases, so it is in so meter only. Here also meter, but here it's not in meter. So we have to find out resistivity. We have to find out. Right? We have to find out resistivity. So what is the formula we can use now? See, check once. Check once. Anybody? Here you can see. So I am considering R equal to 0.25 mm. Normally 1 meter equal to 100 centimeter. 1 centimeter equal to 10 mm. So then 1 meter equal to 1000 mm. So then 1 meter equal to 10 power 3 mm. So 1 mm equal to 10 power minus 3 meter. So this one. So here you can see. Now I am taking. So R equal to 0.25 into 10 power minus 3 meter. So we can also write 25 into 10 power minus 5 meter. So that is the radius. That is the radius. Okay, check once. Any doubts? Check once in that. So now, so we got R equal to 25 into 10 power of 15. So what formula we can use? So R equal to rho into L by A. So R equal to rho into L by A. So here if you want to substitute A, so they given radius. Radius is nothing but so A equal to pi R square. So A equal to pi R square. So you can take this circle, area of the cross section. So now we can take pi R square. So we need to find out resistivity. Resistivity equal to RA by L. Resistivity is equal to RA by L. Now you can check. So shall I arise? Just to try to do it. Try to do it. So if any doubts, you can check. Check once. Any doubts? So here I am taking, so you can consider here. So here radius is given. Radius is given. So here radius is given. Radius you got it. So length you got. So r is there. So we have to find out resistivity. For finding the resistivity, so we can check for finding the resistivity. Now you can check here. Do you have any doubts about it? If you have any doubts, so you can check now. I am okay. So I am erasing it. So this is the formula we have to use. This is the formula we have to use. So after using this formula only, you'll get it. So this is the formula. Okay. So now we will see the value. See this this data is not required. This data is not required. So I am erasing it. So only this formula is enough. This formula is enough. This formula is enough. So rho equal to RA by L. So rho equal to RA by L. So R how much? R is how much? R is 10 ohm. R is 10 ohm. Substitute 10 ohm into pi R square. Pi R square, right? Pi is nothing but 3.14. 3.14. R square is this the R square. So you can take 25 into 10 power minus 5 whole square. Whole square. Pi R square, right? So area equal to pi R square I am taking area of the cross section. So pi R square I am considering. Pi R square I am considering. Okay. So do you have any doubts? So no doubts. So here length. So length equal to how much? Length 75. So if you take 75, so try to do the calculation. So do the calculation. How much you will get it? How much you will get it? So if you do the calculation, so I am taking, if you do the calculation, so you will get the answer. You will get the answer nearly 2.1, 2.61 into 10 power minus 8, 10 power minus 8 ohm meter, 10 power minus 8 ohm meter, 10 power minus 8 ohm meter. 10 power minus 8 ohm meter. So this is the answer. So check once. Shall we go to the next one? Anybody have a doubt? So in this, shall I erase? Can I erase it? So okay, done. So next one. So next question, a current of 500 milliampere flows in a series circuit containing an electrical lamp and a conductor of 10 ohm. So when connected to 6 volts battery, find the resistance of an electric lamp. Here you can see they asked about current is given. So we can see current is given. So we can note down current I given. So current I equal to 500 milliampere. 500 milliampere. Second here conductor resistance RC given. RC equal to 10 ohm. RC equal to 10 ohm. And the resistance of lamp we have to find out. Okay, resistance of lamp we have to find out. And for battery given. Battery, so potential difference is given. Potential difference is 6 volts. So can anyone solve this question? Try to solve this question. So if you have any doubts, you can let me know. Anyway, we'll do it. Try to solve this question. Very, very important question. So these type of questions may come in the exam. So this type of questions may come in the exam. So try to solve it. Try to solve this question. Okay. So very important question. That is, you can observe. So current is given. Resistance of the conductor is given. Resistance of the lamp you have to find out. Potential difference is given. Potential difference is given. Right. So anyone can try to solve it. If you have any doubts, you can ask. So we'll work out. So here I see, I'll give the hint. So we can use V equal to IR formula. V equal to IR formula we can use. We can use V equal to IR formula. Here, so potential difference is given, right? And current. So current is milliampere. Milliampere is given. So I equal to 500. 500 into 10 power minus 3 ampere. So 500 is nothing but 10 power minus 3 ampere we can take. Okay, so 10 power minus 3. So now you can see 6 equal to 500 into 10 power minus 3 into resistance here. So in the place of resistance we have to take RC plus RL. RC plus RL. So here RC equal to 10, RL we have to find out. Okay, so that's enough. Simple. Yeah, so actually it is zooming out and zooming in, that is the problem. That is the reason it's coming like this. Understood. So problem is there. So I'll check it once. So for the next class I'll clarify the zoom. So I'll make sure that camera will be clear. Okay, so next one. So you can see here, so you can take down, so this value 6 by 500 into 10 power minus 3, so equal to 10 plus RC, so 10 plus RL. So we have to find out RL, this value we have to find out. Here we can take 6 into 10 power 3 by 500 equal to 10 plus RL, 10 plus RL, 10 plus RL. So here I am taking 6000 I am taking by 500 equal to 10 plus RL, 10 plus RL, 10 plus RL, 10 plus RL. Okay, so here you can see 0 get cancelled, so 5 12 yeah, so 12 equal to 10 plus RL, so RL equal to 12 minus 10, then RL equal to 2 ohm. This is the answer. So RL equal to 2 ohm. So this is the final answer. Till anybody doubt? If you have any doubt, you can ask. So next question. Shall I go to the next one? Students, those who are there in Instagram, you can join to the student the brand. So there you can get live clearly. So this camera is not clear. So those are there in Instagram. So come to join in YouTube. So YouTube class. So there you will get a clear picture. So clear class. So here some problem is there. Student the brand, coming to the student the brand. So join to the YouTube class. Okay, student the brand. Student the brand. Student the brand. So this is a live class. So there you will get live class. So again, so join to the student the brand live class. So those are there in Instagram. So here next we'll go to the next one. Next question. Find the resistance of a conductor. Find the resistance of a conductor if the electric current flowing through it is. So current is given. So current is 0.35 ampere. 0.35 ampere when the potential difference across it. So potential difference is given 1.4 volts. So current is 0.35, potential difference is 1.4 volts, and we have to find out resistance. Resistance we have to find out. So can we guess, anybody, which formula we have to use? Anyone can guess the formula? So anybody can guess the formula, what formula we have to use? What formula we have to use? Can you guess? Any guess? No guess. So I'll only try. So V equal to IR formula. V equal to IR. So here V we know 1.4, I we know 0.35, and R we have to find out. So R equal to 1.5 by 0.35. So I am taking 100 by 100 because we need to remove these points also. We have to remove in the denominator values. Compulsory we have to remove denominator zeros, we have to remove first. Then anyway numerator also we can do it. So first we have to remove all the zeros, all the points, not zeros, all the points we have to remove. So first you can remove all the points. So now you can take, so you'll get 140 by 35. 140 by 35. Correct only. So then R equal to how much? R equal to how much you'll get? So you'll get 4 ohm. Next, we'll go to the next problem. So how much energy is given to the each coulomb of charge passing through 6 volts battery? The question is, how much coulomb of charge given to the conductor till 9 p.m. class will be there. 9 p.m. class. That time we'll see. Those who are attending through Instagram, so that is not clear. Okay, so you can join to the YouTube class. YouTube classes you can join. YouTube it will be clear. So how much energy is given to each coulomb of charge passing through 6 volts battery? So 6 volts battery. So voltage given 6 volts and charge is given 1 coulomb, and we have to find out how much energy. Energy is nothing but so we know, so work done we have to find out. So we know V equal to W by Q. So W equal to V into Q. That's enough. Simple formula. Can anybody guess the answer? What is the answer? So how much energy is given to each coulomb of charge passing through 6 volts battery? So 6 volts given, Q is given, V equal to W by Q. So W equal to VQ. Anybody? 6 into 1. 6 joule. So thank you so much for attending the class from Siva sir, student brand. Thank you so much. Siva sir. Thank you. We'll see you in the next class.